What's up, guys? I'm just going to do my last lab for physics for the quarter. It's a gravitation and orbit lab. So we're looking at velocity vectors, gravity force, and stuff like that. So all using simulation. So I'm just going to flip the camera around. So this is what we have going on. We're going to look at the relationship between the Earth and the Sun first. So turn on the gravity force, velocity force, path, and measuring tape. I measured this earlier. I won't measure it now, but basically it's 91,902 miles. 1,000 miles is what I got. And so we're just going to look at how much time it takes for the period revolution to come back to the starting point. So actually we'll put this here just so I know where the end point is. Yes. So anyway, as you'd expect, a full year is 365 days, and so that's what this ends up being. Okay, boom. So yeah, measured being 365 days earlier. And so now what we're going to do is that we're actually going to change the distance that the sun and the Earth are apart from each other. Okay, so I'm going to reset this: Earth, Moon, gravity force, velocity, path, measuring tape, and move the star till it's about halfway from where it was originally. Measured that out being 5,000 miles or 50,000 miles earlier. So yeah, like right about there. And then finding the period of revolution for this guy, which is significantly more different, more oval shaped. Boom, right there. So about 91 Earth days, which I think I had earlier. Let's see. I had 77 Earth days earlier, so the distance must be off a little bit from what I had. But yeah, obviously, the distance that the object being orbited is from the planet orbiting it really has a huge effect on the time it takes for the orbit to take place, the period of revolution. Now resetting everything again: Sun, Earth, gravity force, velocity, path, changing the mass of the Earth to 1.5 times its original weight. Okay, so as you can see, the gravity force, the vectors there overlap each other. But interestingly enough, it doesn't change the time for the Earth to go around one full orbit. And based on what I was researching earlier, this is like looking at some websites. This is actually the case. Changing the mass of the satellite doesn't change its period of revolution, which I think is really interesting. But I think it has to do with the ratio of the satellite and the planet being orbited, which matters so much. So yeah, about 365 days. Now comparing this to the relationship between the Earth and the Moon, obviously that distance is much shorter. Gravity force, velocity, path, measuring tape. So just looking at this real quick, I'm just doing a quick measurement. So this is like 245,000 miles. And just looking at that revolution real quick, it's a month, which is expected. Which is boom. Yeah, so 28 Earth days. When we change the distance, however, between the Earth and the Moon, it's a little off, but for the simulation it'll do, by half. Again, another oval shape, and it's about 6 to 7 Earth days. Okay, so again, the gravity force is so much larger, as you can see from these blue vectors, when the distances are so much closer together. So we're basically just looking at the difference between the distance from each object from each other, and then also the mass. And so I'll show you the mass difference now. So again, Earth and Moon, gravity, velocity, path, measuring tape, and then changing the Moon's mass to 1.5 times its original weight. You can see the velocity vectors are much closer. But they do not touch or overlap. And again, period revolution is the same as it was when the Moon's mass was what it should be, 28 Earth days. But if we take away the gravity force, velocity force, measuring tape, and just look at the Earth's position, okay, you can see that over time it kind of starts spinning out. And again, I think that really has to do with the relationship between or the ratio between the mass of the moon and the mass of the Earth, because this is not significantly heavier than the moon. I mean, it is, but not compared to like the sun and the Earth. Like the sun is way bigger than the Earth, where the moon is has a closer relationship between the mass of the Earth and the mass of the moon. So because of that, and because it's a greater weight now, it's causing the Earth kind of come out of place, because that anchor isn't enough to solidify the moon's orbit. But again, it didn't change the period of revolution, which I think is pretty interesting. So yeah, that's the lab. Hope you enjoyed it. Really cool to be looking at planet orbits and whatnot. So anyway, yeah, it's been a good quarter.